Since we began exploring space, we've been searching for answers to one of humanity's oldest questions. Are we alone in the universe? Among the worlds that orbit the sun, there is a giant shrouded in stormy clouds and deep mysteries. A planet that, at first glance, seems far too inhospitable for any form of life, but perhaps appearances can be deceiving. Astrophysicists from the Massachusetts Institute of Technology, MIT, have discovered that certain types of life can survive and develop in environments with only 10% hydrogen. This undoubtedly increases the possibilities for the emergence of life. And within our own solar system, there is a gas planet extremely rich in hydrogen, Jupiter. So, the big question arises, could life exist on Jupiter? Most space probes heading toward the outer planets usually pass by Jupiter along the way. Sometimes they take advantage of the planet's gravitational slingshot effect to gain speed, and even snap a few bonus photos. Because of this, after Venus, Mars, and the Moon, Jupiter is the most explored celestial body by probes in the entire solar system. Jupiter is the largest planet in our system. Excluding the Sun, it holds about 90% of all planetary mass. Even if we combined the other 7 planets, they still wouldn't be bigger than Jupiter. In addition, its rotation speed is extremely fast. At the equator, it reaches 12.6 kilometers per second. If it weren't for its immense mass, it probably would have already torn itself apart from spinning so quickly. In reality, Jupiter's volume and mass are not proportional. It resembles more of an immense balloon full of gas. Its atmosphere is about 50 kilometers thick, and only the core is solid. Scientists believe this deadly core is made of silicates and iron, with a mass equivalent to more than 10 Earths. Overall, Jupiter should be considered the least likely place for life to exist in the entire solar system. For life to emerge on a planet, ideally it should be rocky, with a solid surface where organisms can settle. It must also be in the so-called habitable zone, receiving just the right amount of heat. Not too close to the star, too hot, and not too far, too cold. And finally, it needs to have liquid water, as water is the basis of all known forms of life. Without these conditions, life is unlikely to arise. However, Jupiter has an extremely low temperature at its surface, the visible cloud layer about -147 degrees Celsius. But the closer you get to the core, the hotter it becomes, reaching about 30,000 degrees Celsius at the center of the planet. Jupiter's atmosphere is also extremely turbulent, with chaotic clouds moving at very high speeds and constantly colliding, forming colossal storms. The most famous of them is the Great Red Spot. It is believed that the presence of hydrogen sulfide in the atmosphere, combined with high-energy cosmic rays, gives the storm its reddish color. The Great Red Spot is about 120 kilometers thick and over 250 kilometers long, large enough to fit 4 Earths inside it. In some regions, winds reach 425 miles per hour, strong enough to destroy anything. Overall, Jupiter is practically a hell for any form of life. Freezing with extremely high pressure, intense radiation, and violent storms. But some scientists believe that perhaps we are being too narrow-minded about what life is. We always use the standards of Earth life to evaluate the viability of other worlds, but it's not certain that all forms of life must be like us. For example, inside the human digestive system, there are bacteria called bifidobacterium that are strictly anaerobic, meaning they not only don't need oxygen, but they die instantly when exposed to it. Just as we die without oxygen, they die when exposed to it. Therefore, we cannot search for extraterrestrial life using only the human standard as a reference. Environments that for us would be hell hot, high pressure, and oxygen-free may be perfectly suitable for other types of organisms. To this day, our knowledge of the universe is still extremely limited. Scientists have even imagined the possibility of beings based on ammonia. For these hypothetical life forms, liquid ammonia would play the same role that water does for us, and nitrogen would play the role that oxygen plays here. Ammonia molecules are structurally similar to water molecules, and, in some ways even better, they are more effective at dissolving substances, which would facilitate the chemical reactions of life. If there were a planet covered in liquid ammonia, its organisms could perform photosynthesis using carbon and oxygen compounds to produce organic matter and release nitrogen into the atmosphere. In other words, ammonia-based life is plausible, and who knows, it could even develop an advanced civilization like ours. In this scenario, if these ammonia-based beings observed Earth, they would probably conclude that life could never exist here. After all, to them, liquid water would be an extremely corrosive acid. To their eyes, Earth would seem like a world covered in oceans of strong acid, with constant acid rains. Just by looking from afar, they would judge that there is no possibility of life here. Maybe, by looking at Jupiter and dismissing the possibility of life, we are making the same mistake.